Okay, so today we are going to actually continue looking at graphing polynomials. However, we're going to take a minute here just to review a quick skill that we did previously because it is something that will come back tomorrow that we'll need to use. So we're just going to do a quick review of how to do synthetic division. So just a reminder, if you have dividing by p minus 4, that means you would set that equal to 0. So you would add 4 to both sides. So you would put 4 on the outside of the house, like so, and then take your coefficients and line them up across the top, making sure you don't have any missing powers, and in this case we do not. We have a third power, second power, first power, no power, so that's good. So let's go ahead and put our coefficients on here, and we will be doing synthetic division the rest of the week with 0 remainders. We should be getting 0 remainders, which is what all of these are going to be as well. So let's go ahead and practice that. We're going to put those coefficients across the top, drop that first coefficient all the way down through into the basement, multiply around, and then add. Repeat, multiply around, and add, multiply around, and add. And notice that, yes, we did get a 0 for a remainder. And we have our coefficients of our answer here. We have 1. We started with a third power. We divided 1 out, which means we'd have 1x to the second power. And then we just count down our exponents, 10x plus 3. And since there was a remainder of 0, we don't have to put any kind of a remainder in there. Okay, so that's just a review of our skill here. The second one is just a higher order polynomial. We're going to put that negative 10 on the outside, build our house. Double check, we got fourth power, third power, second power, first power, no power. So all of our powers are there. We're going to put our coefficients 120, 102, 12, and negative 80. And again, if you did it correctly, you should end up with a 0 for a remainder. So we're going to drop that first coefficient all the way down through to the basement, multiply around and add, multiply around and add, multiply around and add, multiply around, and add, and we got a 0 for a remainder. And again, we started with a fourth power. We divided a first power out, which means our highest exponent in our answer is going to be a third power. So we'd have 1x to the third, and then we just take our coefficients and count down our exponents, plus 2x minus 8. Okay, so what I'm going to have you do, take a minute, finish these last two on your own just to practice to make sure you are doing it correctly, and you should end up with a 0 remainder on both of them. Okay, so now we're going to look at some graphing. This is just exactly what we did in the bounce, wiggle, cross activity, just a review, so we're kind of reviewing everything one more time. As we look, the first question says, where are the zeros? Remember, the zeros are where you take and set each of these equal to 0. So if we set x plus 3 equal to 0, that means we'd have a 0 at negative 3. If we set x plus 1 equal to 0, we would have a 0 at negative 1. X minus 2 equal to 0 means we'd have a 0 at 2, and then at 5 as well. Okay, so if we're thinking about our zeros, that's our spots we're going to mark on our graph down here. So we're going to have one at negative 3, okay, at negative 1, at 2, and at 5. Okay, so that's just basically what we did on our first step last time when we did the bounce, wiggle, cross activity. Okay, and what's happening at each 0? Well, let's look at our multiplicity. So our multiplicity at negative 3 is 2. So our multiplicity of 2 means that we are going to bounce at negative 3. Okay, and then at negative 1, we have a multiplicity of 1, which means we are going to cross there. And then at 2, we have a multiplicity of 3. 3 means that we are going to wiggle. And at x equals 5, we have a multiplicity of 2. M is just my multiplicity, if you haven't noticed. And a multiplicity of 2 means that we are going to bounce. Okay, so we know what we're going to do at each of these places. Okay, and then what is the total degree? Remember, the total degree is where we just add our exponents. So we would add 2 plus 1 plus 3 plus 2, and we would end up at 5, 6, 7, 8. Okay, 8 is even. Even means same direction. Okay, and the lead coefficient LC is negative. Okay, that means that negative is going down, and since they are going in the same direction, that means that they are both going down. So what that means is I'm going to put my end behavior in here first. Okay, and then I'm just going to go from left to right. I'm going to start that black graph where I've started it on the left, and the first thing that I'm going to do is I'm going to come up here and I'm going to bounce and come back down. And then in between those 2 points, I'm turning around, and my -1, we decided we're going to cross. So I'm going straight across. And then at 2, I'm just turning around. I'm going to do a little wiggle. Okay, and then at 5, I'm bouncing, so I'm turning around and bouncing back down. So we have a bounce, a cross, a wiggle, and another bounce, which is exactly what we said we would have up at the top. So that's just a review of what we did on that bounce, wiggle, cross activity. And now we're just going to go the other direction. Okay, I'm going to give you a graph, and you are going to have to write a possible equation based on what it's doing at each of the zeros. Okay, so let's look here. I've got a 0, let's do this, here. Okay, that's at -3, so I have a 0 at -3. And if you look at -3, it's wiggling. So I'm going to do a little wiggle there. I've got here at 1, I've got a cross. So at x equals 1, it's crossing. And at x equals 2, it's bouncing. Okay, so just a reminder, if it's a wiggle, wiggle means that our exponent is going to be, oops, I'm going to use my right colors here, means that I would have an exponent of 3. That's how we got, or an odd number. I always use 3 when we're writing any particular equation. So we'd have an exponent of 3 to go with that, because that would make it wiggle. To make it cross, we would have an exponent of 1, or a multiplicity. Technically, we could call it a multiplicity of 1. Let's go ahead and use that correct vocabulary here so that we are consistent. So it would be a multiplicity of 3 and a multiplicity of 1. And then to make it bounce means that we would have a multiplicity of 2. Okay, so what is that going to look like? We would have y equals, because it's an equation, okay? And to have a 0 at -3, remember we set each of those equal to 0 to figure out where it crosses or bounces or wiggles, which means we would have x plus 3. That's how we would get that -3. And it has to have a multiplicity of 3 because it has to have a multiplicity of 3 because it wiggles. And then our next one, we would have at x equals 1, that means we would have x minus 1, because if we set that equal to 0, we would get x equals +1. It has a multiplicity of 1. And then our last one at 2, that means we have x minus 2. That's how we would get that +2 for our 0. And it's a bounce, which means we would need to have a squared. And then we double check for a lead coefficient, right? The lead coefficient, these ends are both going up, which means the lead coefficient would be positive. We don't need to put a number in there. We're going to keep it simple, and we're just not going to put a negative. So we're going to keep it a positive out in front. Okay, so that would be a possible equation for that graph. And again, we knew that and if we double check, so if we did our degree to make sure we're on the right track, the degree, total degree, was 3 plus 1 plus 2, which is 6. And yes, both of the ends are going in the same direction, and the lead coefficient was positive. Okay, so let's look at another one. Okay, here's another one. We're just going to do the exact same thing. We're going to look at what's going on here. Here's a -3, so at x equals -3. We've got here x equals 1, and we've got here at x equals 5. Okay, at x equals -3, we've got a cross. It's crossing. at the other two places, at 1 and 5, it's bouncing at both of those, okay? Which means we know some things about our multiplicity, right? Our multiplicity for it to be crossed, in order to be able to cross, our multiplicity or our exponent would equal 1. A bounce would mean our multiplicity would equal 2, and our multiplicity here would also equal 2, okay? So we would have y equals, okay? To get x equals -3, remember that way we'd have x plus 3, and that would have a multiplicity of 1. X equals 1 means that we'd be at x minus 1, and it has a multiplicity of 2, so that would make it a squared because it bounces, and the same thing at 5, we'd be at x equals -5, and our multiplicity would be 2. However, we have to be careful because if you notice, this side is going up and this side is going down. The right-hand side is going down, okay? Which means if the right-hand side is going down, we would have a negative lead coefficient, okay? If it was a positive lead coefficient, it would be going up on the right-hand side, okay? But since it's going down on the right-hand side, that means it would be a negative lead coefficient, which would be that right there, okay? So your homework for today is just going to be to finish the rest of this packet and submit it to Schoology, okay? It's called Graphing Day 3, I believe, Polynomial Graphing Day 3 or something like that in Schoology. So you need to finish the rest of this packet, which you'll see as you kind of go through. It takes you through writing equations, which is just what we just did. And then again, practicing with sketching graphs and practicing with polynomial synthetic division again. So good luck and make sure that you get it submitted.